Welcome back. The topic of this interactive video lesson is on advanced geometric probability. Let's start by talking about the volume and surface area of geometric solids. In this section, we will focus on calculating probabilities that involve events occurring inside or on the surface of a geometric solid or composite solid. For example, consider this sphere. Notice the radius is 25 millimeters. All of the air has been pumped out except for one molecule of oxygen. The oxygen molecule is equally likely to be in any part of the sphere at a given moment. What is the probability that it is closer to the center than to the edge? We need to find the volume of the space closer to the center than to the edge. Notice that it is a sphere with a radius of the radius divided by 2. The radius is 25 millimeters, so the molecule is closer to the center if it is less than 12 5/10 millimeters from the center. Divide the inner sphere volume by the outer sphere volume to find the probability. Substituting for the inner and the outer, then dividing, we see that we have 12 5/10%. So the probability that the oxygen molecule is closer to the center is 12 5/10%. Whenever you solve geometric probability questions, divide the part by the whole. Try solving this. A bird flies into a hut and is trying to find its way out again. What is the probability that it is in the cylindrical part? Here are the formulas for the volume of a cylinder and a cone. The cylinder and cone have equal heights and radii. Can you find the probability? Notice that the volume of the cylinder is 3 times that of the cone. So 1 part cone plus 3 part cylinder equals 4 parts total. In other words, the odds that the bird is in the cylinder is 3 out of 4, or 75%. Again, when solving geometric probability questions, divide the part by the whole. Let's try a problem involving surface areas and probability. A snail is crawling along the walls and bottom of an aquarium. It cannot crawl along the top. If the snail is equally likely to be on any side or the bottom, what is the probability that it is on the bottom of the aquarium? The bottom of the aquarium has dimensions of 40 centimeters by 60 centimeters. That's 2,400 square centimeters. 2 of the sides have dimensions of 40 centimeters by 20 centimeters. And 2 other sides have dimensions of 60 centimeters by 20 centimeters. Therefore, the total surface area of the aquarium is 6,400 square centimeters. Now divide the part by the whole to find the probability. Notice the part that we want. Dividing, we see that this is 37 5/10%. So the probability that the snail is on the bottom is 37 5/10%. Probabilities with composite shapes may involve 2 or more surface areas. For instance, Raj is painting a model rocket that he made. What is the probability that he is painting the hemisphere? We'll start by writing the surface area formulas for the 3 parts of the rocket. We have the cylinder, the cone, and the hemisphere. The cylinder has a radius of 4 centimeters and a height of 14 centimeters. So it has an area of 352 square centimeters. The cone has a radius of 4 centimeters and a slant height of 10 centimeters. So its area is 126 square centimeters. And the sphere has a radius of 4 centimeters. So its surface area is 101 square centimeters. So in total, the surface area is 579 square centimeters. Now divide the part by the whole. and we get 17 4/10%. So the probability that Raj is painting the hemisphere is 17 4/10%. Let's review the surface area and volume formulas for geometric solids. For a cylinder, here's the surface area of the base, lateral surface, and total. The volume. For a sphere, here's the surface area and volume formulas. And for a cone. For a square-based pyramid. For the rectangular prism. And for a triangular prism. You might want to write these down to have them handy. It's a good idea to keep a copy of these formulas at your fingertips as you answer the questions that follow. Alright, now you're ready for more examples and practice.